The purpose for today's meeting is try to explain how to do project 2 on page 611. I told the student I watched the video load on for the programming project 1 at page 611 to get some idea. You got the idea, but the implementation will be a little bit different. This is a good example to show students when you design a class, what is really matter. So when we have a class, for example, CD account, this class, a class you have a public session, another is a private session. Public session is an interface provided to the people who use your class. So when normally for those interface, you need to write down so-called precondition, post-condition to explain each method, what those methods will do. But since this class, the method name explains itself, so I really didn't put any comments here. For example, get initial balance. Well, read the name of the method below. This will get the balance of this CD account. Then get a balance after maturity. Then below, this method will return you the balance after the maturity. Notice when I design those methods, I put a constant after this method name, which means this method should not change the private attributes value of this class. So it's just a return value, will not change any values. Okay, and I gave you this template. Students should follow this template. And the first step, students should understand the class design. So let us go over this class design. This class is talk about a CD account. So you first have constructor. This constructor CD account will create a CD account with all those like a zero balance, zero interest rate, and the term is also zero. It's just a CD account with nothing inside. Now, second constructor created a CD account with given new balance, given interest rate, and given new term. So basically initialize this account will be able to. So the other method, for example, get initial balance will return you the initial balance of this CD account. Get a balance after maturity will return you the balance after the maturity. Then get interest rate will return you the interest rate of this CD account. Then get a term will return you the term of this CD account. Now we also implemented two methods. One is input. Notice this input take a I stream as an input as an argument. This method. So this I stream can be C in is an I stream. Now this output take an O stream object as argument. C out is a built-in O stream object. So if you use C input here, that means you will get input from the keyboard. You use C output here, that means you will output to the screen. So those are the public session. Those are the methods people can use if they decide to use your class. Now pay attention is people don't need to know how you implement those methods. As long as your methods provide the functionality you promised. For example, you promise people if you use my input, put a C in here, then you can take an input from the keyboard to input the information of this CD account. So people really don't need to know how you implement this input. So basically, as a student, after you read those class declaration, you should already be able to write a main function without implement this class yet. You already be able to write a main function. You don't have to know what are the private attributes of this class. Okay. For example, let us implement the main function first. We write a very simple main function. What we do, we ask user to enter a CD account information, then print out the balance at maturity. Okay. So suppose I want to write such a simple main function. So what I can do? I can just say, for example, I can say this. I say CD account account. I declare variable, right? Then I print out a message, cout, enter account balance. Now, well, this time you did low. People will tell you his balance will be in. You only need to load into the balance as the dollar, like $127, $127.56. Okay, into the balance. So right, and this is if you decide to call this constructor. Okay, if you decide to call this constructor, so you get the balance. You have two ways to do this. One is into the balance. So then you get in this case you need to declare a balance variable, like a double balance equal cin double balance. You declare first, then you cin balance. But for this object-oriented program, I really don't have to. I just say enter account information. Right? Now, then if your input method designed very well, I can just simply say cin account, because I should be able to do this. Now, let's say if since I already declared this, right? I should not say cin account. I'm sorry. We should say input account. Input account, because my method called input. Okay, input account. My mistake. Account dot input cin. So this, because input is a method of this account CD account class. So account as an object of CD account, which means this account has this input method. So I just say account dot input cin. That means I take cin is a built-in iStream, so I can use this to input account information. Now, then you might wonder what happened here. Well, is the people implement this input method will handle this. Okay, the guy input this input method will handle this. So for those guys input this method, if you notice, he will input the interest balance first, then will enter interest rate, then will enter the term. But for the user, he will not see this implementation. So as a program, when you implement this, you might want to add more sentence in this input method to give user more hint. For example, here you will cout enter the account balance you will do this. Now, then the program will wait for user to type in the balance. Then after that, your program will calculate this balance equal how many dollar, this balance equal how many cents. So like if user enter $127.56, then 127 will be assigned to dollar and 56 will be assigned to cent. Why? Because you are the one implement this class, so you know you have private attributes. One is dollar, one is cent. Dollar and cent together represent your balance. So in this case, if user enter balance is 127.56, then the program shall assign 127 to dollar and 56 to balance to cent. So you say this program, he did this in purpose. He tried to tell you the idea that it doesn't matter what you use to represent the private data. You could just use one double value called balance, represent whatever this balance belong to this account. You also can use two integer attribute like a dollar and a cent together to represent this balance. It doesn't matter how you do it. But if you use this way to represent the balance, then when you implement your code, you need to make sure that when user enter $127.56, you will assign 127 to your private attribute dollar, assign 56 to this private attribute cent. So after this, you can print out, see out, enter the interest rate as decimal. So now, in this case, which means if interest rate is 5%, user supposed to enter 0.05. If you after the user don't know what to do, you say 5% entered as 0.05. So your program will be more clear for people to understand. Now, then you add more sentence here. See out, enter the term as number of months. So then you enter term. Now this code, after you modify it, you say when people use your code, he call in this main function, he call account.input cin. Then the program will be again to execute this part of code. He will first print out in the account balance. Oh, user know what to do. Okay, I type some balance. Then your code calculate behind the screen. User don't know what happened. You calculate what is based on this balance, what is dollar, what is cent. Then you assign to your CD account object his private attributes. Then you ask user enter interest rate, tell the user exactly what to do, then enter the term as number of months. Now the user know what to do. So you say, as a user to use your program, he really don't need to know what happened in this input function. He just need to know how to use it. It's account.input cin, because your public interface says so. Your public interface says so. Okay? Now after this, then print out the balance at maturity. Then the user just need to print out the balance at maturity is, if he want to print out a dollar, he just need to use account.get balance at maturity. Now then you return 0. Your program finished. So you say for the this is a good thing for the object-oriented programming, right? The user just need to use the function you provided. Okay, he don't need to worry about anything else. How you implement the function, he don't need to know. You actually can print out more information. For example, you can say account information. You can do this. See out, initial balance, then you can use account.get initial balance. Okay, you just call the method. Now you when you use this class, you even don't care how he implement, as long as his function method provided the functionality it promised. So you can just go ahead and use it. So from now, I always suggest students, you write the main function first to help you understand the class you need to implement, what this class actually will do. You really don't implement the class first. You write the main function first. Okay? Now, then you can say, see out, interest rate, then you just use account.get interest rate. Okay? So, of course, you can print out a new line. We probably want to print out a new line, and L. And this one, you want to print out a new line, and L. Okay. Now, then you want to print out the term cout. I type it wrong. Cout. Okay. So I type cout. Then you will say, you also can say call what? I will have term. Okay, term. Now then you will say account dot get term. Okay. Now you can do this, but there is an easy way to do all those. Why? Because those account information should be the functionality that output can do. Okay? So this function, what this function do? Output the account information. Okay, so which means what? All those actually user who use your class don't need to worry about it. If you want account information, he just need to call you output function. So what I do, the idea is you actually don't need this. You need to put this inside this output function. So let me comment this away first. Then I begin to implement this output function. Okay, so let's implement this output function. So I will say void CDA account colon output then this function I will implement it in the way like this. Okay, so I copy this code here. Okay, now this output function, let me say what do we miss is stream out void accd account output colon. I did not make any mistake, right? Why there is something not right? Stream. Oh, I missed one thing. No, I didn't miss anything. Come on. Then I will use out. I will use out. Okay. I will use out here. Out to print out all those things. I can't dot. Oh, I don't have account, so I don't need account because this time is this method itself. This object itself. So I just do this. I get rid of this account. Okay. Then I will do here out and get rid of this account. Now, why? Because this time output is a member function of this class, right? So he can call this class method, okay, other method directly. So basically now this output function is a CD account, his member function. If you call this output function, and it will print out this account information. So now, as a user, don't need to know how you implement it. I just need to know there is a such function. So what I do, I will after input the account, then I just account dot output, and I want to use cout as output. So I do this. So you see your main function. If the simplest main function only 3 lines of code. First, ask user enter account information. I use the method you provided called input method. So I just say account.input, say in. So I allow user to input account information from the keyboard. After that, I call the function account.output. Cout, I allow the output to be to the screen. Okay? So you can see your main function is very simple, very simple. Of course, you can have more, right? Now we need to implement the rest of the functions. we begin to implement the rest of the function. If you pay attention, so far you see the low syntax error, which means at this time you can, if you compile this program, you will be okay. But you cannot run the program. The reason is in your code you will use some other functions. Before you implement those functions, you will not be able to run it, but you can compile it. So there is no compile error. But if you run it, you will have an error message say cannot find the definition of those functions because you did not implement it. So let's implement the rest of the functions. For example, let's implement this one. Okay. So you can always do this. You can always copy it. For example, then you put it here. Begin to implement. So you need to have another CD account, canon, right? This is a constructor. So constructor supposed to initialize all those private attributes. So you can say dollar equals 0, cent equals 0, right? Interest rate equals 0.0, and your term equal 0. So you just basically just create an account, has nothing inside there, but you still initialize every one. Your book has an easy way to do this. You guys go ahead and read the book to find out how you can do it. You can put this initialization on the head of this method. You can find out how to do this in the book. Okay, now let's do the next constructor. So you copy this. Okay, make sure you do not copy the semicolon. There is no semicolon here. So you put it here. Then you type one more CD account canon. So this, which means this method is belong to CD account class. Now for this one, you really want people give you a balance. You need to initialize your private attributes. So you really need to convert this balance to the dollar, then convert this balance to the cent. Now we already have it here. Okay, so I just copy it. Because you give me a balance, then but I need to change the name called new balance. You give me a new balance. From this new balance, I get the dollar. Then from this new balance you give to me, I will get the cent. How to from the balance get dollar? If you have $127.56, that's your new balance. Then 127.56, I only use his integer part, which is 127. That's my dollar. Then I use 127.56 minus 127, I get 0.56. Then I use 0.56 multiply 100, I got 56. But this 56 is a double value, I cast it down to integer. So I got an integer value 56 cents. Okay, that's how I initialize this. Then interest rate. So I just directly interest rate equal new interest rate. Then I just use term equal new term. Okay, so this is how you do the constructor. So I finish constructor. Now I begin to do the rest. For example, do this one. I will just copy. Every time you copy those, don't copy semicolon, but you need to copy everything else. So double CD account canon, get the initial balance. Okay. Now, since get the initial balance, of course, I just need a return balance. But what will be my balance? My balance will be dollars plus cent divided by 100.0. Now, why I use 100.0? Because cent is an integer. If I just divide by 100, integer divided by integer will still give you integer. Since cent is less than 100, divided by 100 will always give you 0. That's not right. So after you divide by 100.0, then this will give you a double value. An integer dollar plus double value will give you another double value. So this together is your balance. For example, if your dollar is 127, cent is 56, then this will return you 127.56. That's exactly the balance your account has. Now, pay attention here. The outside doesn't know how you represent the balance. He didn't know you use just one double value, or you use dollar or cents, or just use pure cents. He don't know. He don't need to know. He just need to know if he call this method get the initial balance, he will get the balance. That's the important thing. So the next one, you want to get the method called those. Let us try to do the easy way. I copy everything over first, then we begin implement one by one. Okay, so we don't need to refer back all the time. Now you just make sure first you delete the semicolon, then make sure you add CD account column. Also do the copy, paste, and delete semicolon, and delete semicolon. Now, then all those need to return. Now, get a balance at maturity. Then we need to use the calculation, do the calculation. So what I can do is I first double balance equal get initial balance. First, I call the method balance get initial balance. Okay. Now, after get the initial balance, then I will calculate the balance at a maturity. So I just simply return what? Return balance multiply 1 plus, right, your interest rate times term, now divide by 12.00. Okay, now this is the formula. You use interest rate times term, because your interest rate is already in the decimal form. 5% is already 0.05. So you just go ahead and do this way, right? Then divide by, because your term is in months, I need to convert it to the year first. Term divided by 12.0 is a year. Okay, so that's your balance at maturity. Then get the interest rate. You just return interest rate. Then if you get a term, you just return term. Okay, so now after you finish all those, I believe we are ready to run this program. Okay, so let us try out one. So let us type running. Oh, I need to say build success. Then here is the thing. Let me go up. Now into the account information. First into account balance, right? So let's say I have $10,000. Then into interest rate as decimal, suppose I have 0.05%. Then into the maturity, suppose we have 1 year. 1 year we know we will get $500 interest. We just use this to test, right? Now, then he say your account initial balance is this, your interest rate is this, term is this, all right. The maturity is 10,500. Yes, we did everything right. Now, after you say you did everything right, then you can begin to improve the output looking. For example, this one, I might want the, oh no, how can I make it go down? Huh? Okay. Now, I might want here, after print out everything, I want here also print out a new line, because after I look at it, I know to improve my program looking, right? Now, in the when people say into the account information here, okay, but in the main function, I also say into account information, right? So it's kind of repeated. Is that right? No, I don't have into account. I just need a new line here. So I put a new line here. So when people use this, when I run the program, will be after say enter account information, then call my function. My function will go to the next two line, begin enter account balance here. So make the program output look a little bit better. So let's run again. Okay, you see, enter account information. Now this look much better than before. Let's try again. This time I have $10,000. Into interest rate, suppose I have 10%, which is 0.1. Then suppose I make it a 2-year, 24. So that means I will have $2,000 interest. So I have $12,000. So you see, now his initial balance is $10,000, interest rate is 0.1, and the term is 24, and the balance at maturity is 12,000. Okay? Okay. Let me stop here, then take a student question.